Okay, good morning. So we start this module by the topic of improper, or sometimes called generalized integrals. So the notes are ready, but hopefully today the projector is working fine. And by the way, when I upload the videos, in the description below the video, I put the link for the file. So if you are looking for it, you can also find it there as well. So if you remember when we were talking about integrals, what type of functions we were facing, we were discussing the functions which were bounded, and the interval was the closed interval. Yes, when I say closed interval, automatically means that the interval is bounded. Yes, so in the normal Riemann integrals that we discussed, we had a function f, and we had a closed interval. When I say closed, b cannot be infinity, because when you put infinity, you are not allowed to include it. So when I say closed interval, automatically I mean a bounded closed interval. So f is bounded, yes? This was the starting point, and this one is also bounded. So there were two limitations we imposed on Riemann integrals. The function should be bounded, and the interval should be bounded. Now here we want to discuss about if we can relax one or both of these conditions, and if it happens, how we can actually make a theory out of it. Okay, so the first thing we want to do is we want to relax the boundedness of the interval. Okay, so for example, I have a function f which is still bounded. But instead of looking at these intervals, I want to look at these types of intervals. It starts from a, goes to infinity, or it starts from minus infinity and goes to some number b. Okay? So now I want to replace this bounded interval by unbounded interval. And of course, the next unbounded interval naturally will be if I start from minus infinity and go directly to infinity. So these are unbounded intervals. Okay, so let us start with this one. Okay, so let us say that f is a function which is continuous on this interval now. Or in principle, you can replace it by the word integrable, but I don't want to make trouble for you. For your course, it is enough to consider that f is continuous and the interval is given like this. So I want to give meaning to this expression, integral of my function, dx. It starts from a, but it goes up to plus infinity. So this is a Riemann, an improper integral of the first kind. If the interval is not bounded, either this one or that one or that one, we say that the integral is an improper integral of type 1. But if f itself is somehow unbounded or has some singularities within the interval which is not defined, then we also call it an improper integral, but of the second type. We can also have a mixture of them. Okay? But let us first talk about improper integrals of the first kind, or of the first type. So it means that I want to keep my function well behaved, for example, continuous everywhere, at least on this particular interval. But I want, for example, to see what happens if it goes infinity. This is definition, so I put semicolon equal to. I replace infinity with a number r, but of course I am assuming that r is a number within this interval. So I'm assuming that r is greater than a. And then calculate the integral. Okay? But let me ask you one question. First of all, this is a definite integral, and that is the standard definite integral, yes, because the numbers are bound. So this becomes a number, but do you agree this number depends on what? R, on my choice of r. So in principle, this is a function of r. And then if I calculate the limit of this function of r and send r to infinity, then if this limit exists, I say that this integral converges. And if that number is 5, for example, I would say that this integral converges to 5. Or we can say this integral is equal to 5. Okay? And if this limit does not exist, I would say that the integral diverges. But when I say the limit does not exist, it does not exist, there are two options. Either this is infinity, plus infinity, or minus infinity, or it does not exist at all. Okay? So if it does not exist at all, I simply say that the integral diverges. But if this limit is plus infinity, I can say it diverges to plus infinity. And if it is negative infinity, I can say that this integral diverges to negative infinity. So, is that clear? And then I do not have any problems in constructing these functions of r. For any r chosen within this interval, this is a number, really. Why? Because I'm assuming that f is continuous on this. F is continuous on this interval, so it is also continuous on this interval. And if it is continuous, it is integrable. So I do not have any problems in calculating this. Okay. So I want to make everything short, and I want to ask your opinion now. So what do you think I will define the other way for this interval? Both of them are improper integrals of type 1. So I start from minus infinity and go to some number b, and I want to define it. So how do you think I will define it? Just from the intuition you got from this definition, how do you think it's a good definition if I want to do something similar to this? What should I write? I should write an integral, okay, from r, for example, to that b, f of x dx. Again, this will be definitely a number which depends on r. And then I take the limit, but this time I will send r to minus infinity. And the same things, diverges, converges, and things like that. But this one is a little bit more subtle. I will talk about that later. But is there any question in the definition? Okay, so let us do some examples first. So let us start with these two examples that you see. So I will write them on the board, okay? So the first integral is integral from 0 to infinity, and I have x divided by 1 plus 2x squared dx. Okay? So the question is, evaluate the following integral or show that it diverges. Because there is no guarantee that this integral exists. First of all, you immediately realize this is an improper integral. How? Because I see that I have infinity in one of these limits. And this is a first type improper integral, yes? So if I want to answer this question, I have to use the definition. So what I will do, first of all, I will construct a function which this one is replaced by r. So I will consider integral from 0 to r. So 0 is the same, but I replace infinity with r. And then x divided by 1 plus 2x squared dx. This is the way I usually do that. This becomes a number, but that number depends on r. Because it is integral, I prefer to write it I for integral, and because it depends on r, I will actually write it like this. Okay, for me it is simpler to do the calculations, and when I find my I, the function I, and then I will calculate the limit. So for the time being, you can momentarily completely forget about what you have now. This is just an old problem, and hopefully we know what to do. So this means that I have to calculate this integral. What is r? I don't know. R is a positive number, whatever it is. So how can I calculate this? So this is just not a new lesson anymore. The new lesson is finished here. This is the old lesson. So how should I calculate this integral?
Arctangent.
No, it's not arctangent because there is an x up there. So that's u substitution. Yes, you can do u substitution because the one that we had didn't have these two. So you can factor these two and use the formulas we had. But let us do u substitution. Why u substitution is good? I told you before, if you take this u, what would be the derivative? The derivative would be 4x. It is not exactly 4x, but it is x with a different constant, so that's not a problem. So u substitution is a good choice. So I would say that I will introduce u to be 1 plus 2x squared, but the rest of it should be automatically done. So the du becomes what? 4x dx. But you see that I need x dx, so this motivates me to divide everything by 4. So x dx that I need is 1/4 of du. And then do you remember I have to take care of the new limits, new bounds. So how should I do that? I would say that x in this problem goes from 0 to r. This implies something for u. U goes from where to where? If x is 0, plug 0 here, u becomes 1. If x is r, plug r here, u becomes 1 plus 2r squared. Yes? And then what we do, we put everything back into here and calculate I of r. So I of r becomes integral. Instead of going from 0 to r, I go from 1 to 1 plus 2r squared. And then, instead of x dx, I put 1/4 of du divided by u. Yes? And then we calculate. So 1/4 goes out. So du over u, it's famous. It's ln of absolute value of u. But I have to run it from 1 to 1 plus 2r squared. Yes? And then, of course, I replace u with the upper limit. But do I need absolute value? No, because 1 plus 2r squared is definitely positive, so I don't need to emphasize on that. So I just replace it with a pair of brackets. And then minus 1/4. I replace u. By the way, we don't need to write it because ln of 1 is what? 0. So let us just skip it. Okay, so this means this is your I r. Okay? And now what I have to do when I have my I r, I calculate the limit and send r to infinity. So this means that now I take the limit of I r when r goes to infinity. So this becomes the limit of 1/4 ln of 1 plus 2r squared, and then r goes to infinity. Okay, tell me what the answer is. R goes to infinity, so this is infinity. Ln of infinity is also infinity, divided by 4 is infinity, so that is infinity. But what do you write at the end? Therefore, the integral diverges. But it is better to say diverges to plus infinity. So that's the idea. Yes? The next question, as you see on the notes, is integral from 0 to 1. What was the first example I missed? Oh no, that was definition. Okay. Because you know that in mathematics text, I am numbering everything one after the other. So when I have 6.3, the definition is 6.4. Then it is easier to look for things you need. Okay, so this is the first one. The second one is also, I have taken it from your book. So the function integral is integral from 0 to infinity. And then I have sine x dx. By the way, I have written it again. So if you don't mind, might be it is better to also see a minus infinity this time. Yes, I'm deviating a little bit from what I have written here. So I just want you to know there is no big difference between them. Okay, so how should I understand this question? Immediately, because of the existence of this minus infinity, it is clear that I am facing an improper integral. Of which type? Of type 1, because I see an unbounded integral.
Which example is this?
Pardon? Pardon? No, I changed this because both examples are with positive. It might be from pedagogical point of view, you see also a minus infinity. It doesn't matter. So, the first thing you do is exactly as before. So what do you define? You see exactly like this. I define an I sub r. How? I would say that I go from r to 0. and then I have sine x dx. And I calculate this integral. Okay, so let us do that. This is very simple. So what is the answer? A primitive function for sine is minus cosine, but I have to run it from r to 0. So this means that I replace cosine x with 0, so it becomes minus cosine 0 plus cosine r. But cosine of 0 is 1, so this becomes cosine r just minus 1. So this means that the function I have is cosine r minus 1. And then I have to take the limit. So I calculate the limit of r goes to negative infinity. Yes? Okay, so this becomes the limit of cosine r minus 1, r goes to minus infinity. Is that understandable? This time I am sending to minus infinity. But what is your opinion about this limit? Yeah, so this limit simply does not exist because cosine oscillates up and down, yes? And of course you cannot say plus infinity or minus infinity because you know that cosine r is maximally 1 and minimally minus 1, so it is definitely bounded. So this means that this limit does not exist. When you say this limit does not exist, you have to write the final answer. So hence, the integral diverges. But diverges to what? We don't know. Because there is no limit for it. Just simply diverges. Okay? Okay, now let us go to this one. So to this one, if I want, probably you can guess what type of integral you might face. An integral of this type. Integral from minus infinity to infinity f of x dx. So we want to give give a meaning to this. So I want to define it for you. You know that in mathematics we have definitions and then we have theorems that we have to prove. So, but intuitively, many students I have seen, they define it in this way. Do you have an intuition about how to define this? As according to this. Might be you say that, okay, I would write from minus r to r, and then fx dx, and then send the limit of this and send r to plus infinity, okay? Okay, so this is not the definition mathematician has chosen for this one. So this is not the definition, so let me cross it over. Okay, intuitively it seems correct, yes, because I go from minus r to r, and when I send r to infinity, it seems that it becomes from minus infinity to infinity. It is reasonable, but this is not the definition that they have chosen. This is called Cauchy. If this number exists, this is called the Cauchy principal value. We will talk about this a little bit later. But the definition is this. If integral from minus infinity to infinity, this seems a little bit subtle definition. We say that this integral converges if for every choice of number c, these two integrals converge. Whenever I don't put plus, I mean plus infinity. So we say that this integral converges if for any choice of c, any number c, both of these integrals converge, yes? And in that case, we say that the value of this is equal to this plus that. If, I have written it clearly in my notes, so I am just talking them orally, but at least you can see the definition in front of you. See, let f be a function that is continuous, as before on R. The integral from minus infinity to infinity is said to converge if for some, for some real, if for some real, I made a mistake. if for some real number c, both of these integrals converge. If for some c, you don't have to do it for a lot of c. The reason I was confused because I never used the definition. I will tell you in a while. In that case, the value of this integral is the sum of these two. Okay, and moreover, this integral is said to diverge if this does not happen, meaning that for any choice of c, at least one of these two integrals on the right hand side diverge. Okay, so I hope that you agree this is a subtle definition. The definition tells you that we say that this integral converges if you can find one c for which both of these integrals converge, and then of course in that case you would say that this number is equal to the sum of those numbers. So it seems that it is very hard, because how should I know? For example, I put 0 there, I check it doesn't work, but it doesn't mean anything. I have to check another number, or I have to check another number, okay? And if I want to say diverge, it means that I have to show that for any choice of c, no matter what that is, at least one of them diverge. So I hope that you can see this is a subtle argument. But I have guided you through it. If you have time, I can also go through them. So it is not important what you choose for c. If it works for one c, it will work for every c. And if it doesn't work for one c, it will not work for any c. Okay? So it is not trivial, but the proof is not very hard. So I have guided you here. So the definition of the improper integral is independent of the choice of the splitting point c. Specifically, if these two integrals both converge for a particular real number c, then they will converge for any other real number c prime. So it doesn't matter. And then the good news is that if you use c and then add them up, it will be the same if you use c prime and add them up. So because of that, it is not that hard. Okay? And I have guided you through this example towards a proof. For the time being, if you don't mind, let me just leave it. But if you have time, because there are many subtleties that comes in this topic, then I will come back to you here. But for the time being, let me give you the message. So I gave you the precise mathematical definition for it. The mathematical definition seems very hard, because how should I know that there is a c? If I work with one c, it doesn't work, I have to check another c. I have to check another c. But the mathematicians have a theorem. That theorem is actually very simple. I have brought it as an example, and I have guided you towards the argument. Then they have proven that if it works for one c, that's enough. Okay, it will work for any other c. So this means that somehow this c is arbitrary. So you can pick any c you like, and then work out this one and work out this one. If one of them turns out to be divergent, you immediately stop and say that the original integral is also divergent by definition. If one of them works, then you have to go to the other one. If the other one also works, then you say that this integral converges. And if they ask you what is the value of this integral, you have already done these two, add them up, and that will be your answer. Is that right? Okay. And then this definition usually sometimes coincide with this definition, sometimes doesn't. So this is not the real definition. I will talk about it. So any questions here? Understandable? And if this c doesn't matter, usually which c is suitable to choose? The simplest one, 0. So that's why in the book they have written 0 only. So if you see in the book, you see 0. So because the person who wrote the book knew that there is no difference. So he started with 0. Okay? But this is the correct definition. Okay, so now let us see that this is not as hard as it seems. I will come back to this remark a little bit later. But let us first try to do these examples. But that remark is also important. I will come back to it. So these integrals are given. The question is that evaluate each of the following integrals or show that it diverges. You should also note what type of questions you will face when it comes to these improper integrals. So let us do some of them, because I think if we have time, let us do all of them, because that's important. So it's easy but important. Okay, so we want to know what happens for this integral. Yes. So this is still of the first type, but both bounds are infinity, minus infinity to infinity. So this should be the newest. So if you want to do that, you need to consider two integrals. And I told you it doesn't matter which c you choose, we choose the simplest one always, unless we have a good reason not to do. So we 0. So I will consider two integrals. So I will consider from from minus infinity to 0 e to power minus absolute value of x dx. And I also consider integral from 0 to plus infinity e to power minus absolute value of x dx. And I have to consider them case by case. So what is the first one? So for this one, we already have the definition. Yes, this one. For the other one, we have this definition. So we have to do two problems, okay? So I will define I sub r, for example, for this one, integral from r to 0, e to power minus absolute value of x dx. Yes, and I told you that r is less than b. So here r is assumed to be less than 0. So this means that this is on the negative numbers. This interval is always negative. So can I replace this absolute value? Yes, because x goes from r to 0, and I'm assuming that r is negative. So x is negative everywhere, so I can remove the absolute value sign, but the price I have to pay is to replace it with minus. So it becomes integral from r to 0, e to power positive x dx. And then I calculate this integral. This is the simplest integral ever. So it becomes this function, and it goes from r to 0. So it becomes e to power 0 minus e to power r, which is 1 minus e to power r. Okay, for this one, I have to take the limit and send r to, okay, so what should I do? I calculate the limit of I of r, but then I send r to minus infinity. So this becomes the limit of 1 minus e to power r, but r goes to minus infinity. Tell me what the limit is. Yes, because r is very huge negative number. So it becomes 1 over e to power a positive huge number. So it becomes 0. So the limit becomes 1. Okay, so what can I say? I can say that this first integral converges to 1. Yes? But now, for the other one, let me call it j of r. So j of r, I call it integral from 0 to infinity. So 0 to r. E to power minus absolute value of x dx. Are you following what I'm doing? So here, this one is from minus infinity to 0. So I chose IR from r to 0. This one is from 0 to infinity. I am choosing from 0 to r. But because that is the different integral, so I called it j. If you want, you can also change the letter r. It doesn't matter that much. But tell me, what can I do with the absolute value here? I am working, r is positive in this case, r is above 0. So this is the positive numbers. X is always positive, so I can remove the absolute value safely. So it means that this minus sign will survive. And then, of course, a primitive function for this is simply minus e to power minus x. These are very standard ones. And then I go from 0 to r. So when I put r, it becomes minus e to power minus r, minus, if I put 0, it becomes 1. So now I calculate the limit of j of r when r goes to positive infinity. So this is the limit of minus e minus r minus 1. Yes, r goes to infinity. So what the answer is?
-1.
Yes, it is minus 1. Have I done anything wrong? It's very strange. It shouldn't be minus 1. Yes, this is plus. Because when I put r, it becomes this one, and minus the other one, so it becomes plus. Do you agree? So the answer becomes 1. When I replace x with r, it is minus e to power minus r, but minus, I have to replace x with 0. There is also a minus, it becomes plus. So that's also 1. Agree? Now, what do you say? Because both of them, if one of them diverges, you stop there and you say that the integral diverges. You don't continue. But when I calculated the first one, it worked, it converges. And the second one I have to do it, and also it converges. So what can I say at the end? So the integral, the original integral, converges to what? To 1 plus what? Which is? So that's the answer. Yes, please.
E to the power of minus absolute value of x is an even function. Can you use that idea to say...
No, that's not a good idea. You know why? Yes, you can use it after you replace it with r. Yes? And then unfortunately when you replace it with r, that's not working. So, but you can do some tricks. For example, you can say that I do some variable change. Then it is very clear that this integral for r will be equal to the other integral for the same r by just some substitution. But I intentionally did it in this way because this is the correct way. Yes? So the next example will show you why. For example, in this example, what is your guess? So, for example, if you see this example, what type of function you are facing? It's an odd function. Yes, because if I replace x with minus x, it will pick up a minus sign. But then let us calculate this integral to see what happens, okay? Yes, so here in this problem, the Cauchy principal value is the same as the value of the integral. But I just want to spend time on what we are supposed to do. But I want you to do it this way. If you want to do some shortcuts, you have to be careful about what you are doing. Yes, please.
What if you have something like cos?
What do you mean?
Integral of cos from minus infinity to infinity, cos x.
You have to do the same. But for example, for cos, if you don't mind, let us take it for sine.
Yeah.
So if it is from minus infinity to infinity for sine, you do the same thing. You go from minus infinity to 0, for example, and 0 to infinity. And then you work the first one out, you realize the first one does not exist, so you stop there and say that the total integral diverges.
Okay.
That's it.
But does it, do you say does it diverge to infinity? Or
No, as I told you, this does not diverge to infinity. This limit simply does not exist. It does not go to infinity because it is impossible for cosine r to go to infinity.
Yeah.
Yes. You're welcome. So let us do number 2. Okay, so if I want to do number 2, it's integral x over 1 plus x squared. So these are good examples, so let us do them. So integral from minus infinity to infinity, x over 1 plus x squared dx. So what I was telling you before, do you remember, if we had some scenario like this, and I know that my function is continuous, and if this is odd, then what was the answer? Was simply 0. This function is still odd, because if I change x to minus x, the denominator does not change, the numerator picks a minus, so it is an overall minus sign. So it is an odd function, and it goes from minus infinity to infinity. But don't think exactly that it has to be 0. It might be equal to 0 at the end, but it might not be. It might be that this is not the case. So you have to be careful about that. Okay? So you have to follow definitions. Well, the definition is simple. Instead of calculating this one single integral according to the definition, I have to consider 2 integrals. And then of course, which number I pick for C, if there is no stress for it, I will pick 0. So this means that I have to consider 2 integrals first. Integral from minus infinity to 0, x 1 plus x squared dx. Another integral from 0 to infinity, x 1 plus x squared dx. I myself prefer to start with the positive one, because if this does not work, I will stop and say that the integral diverges. And if it does not, if it works, then I have to go to the negative. Working with positive is probably simpler. So this means for this one, I have to introduce a function which is integral from 0 to r x over 1 plus x squared dx. Yes? Okay, and now if I ask you, how should I calculate this? This is one of the famous one that was the extra lesson. It is a famous integral. If you remember it, use the formula. If not, use the substitution. I derived that for you there. But do you have it in your memory? Yes, it is 1 over 2 ln of 1 plus x squared. So I am using my memory from that. If you have forgotten, then you take this u, this becomes 1/2 du. Okay? So, and then I have to run it from 0 to r. Okay, so what happens now? If I replace x with r, so this becomes 1 over 2 ln of 1 plus r squared, minus, if I replace x with 0, it becomes ln of 1 is 0. Yes? So that's it. And then you see that I don't need even to continue anymore. So, I have to take the limit of I of r, and I send r to infinity. So this becomes the limit of 1 over 2 ln of 1 plus r squared. R goes to infinity. What the answer is? Infinity. Yes? And I stop. Because even if the other one is convergent, it doesn't help me. One of them diverge, I stop and say that the whole integral diverges. Yes? So therefore, we don't need to work out the second one. The integral diverges. Okay, but if you insist to say to which value it diverges, so there is no way, you know, if what, do you have any guess about this integral? If you think, if I can redo the calculations again, the calculations is not hard because the function is the same function, so the primitive function remains the same, but when I run it from r to 0, what will happen? This becomes just minus 1/2 ln of 1 plus r squared. Do you agree? And if I send r to infinity, what happens? It goes to minus infinity. So one of them goes to plus infinity, and the other one goes to minus infinity. Still, I cannot say anything about the total integral. Because if one of them is plus infinity, and the other one is minus infinity, infinity minus infinity is an indeterminate form. So this is the best I can say. I can just simply say that the integral diverges. Yes?
From a graphical perspective,
Yes?
since it's an equal function and everything, is it because that the function is not bounded as a whole on the interval minus infinity to infinity?
It is bounded, isn't it?
It's bounded.
Isn't it? I don't know. This function is always less than x. No, it is not bounded, probably you're right. Have you drawn the graph here in front of you? You don't have it?
No, not yet.
Yeah.
But I think that's one of the reasonings why we can say that the integral from 0 to infinity diverges.
No, because this integral, this is bounded, because if I take this one, absolute value of this becomes the absolute value of the numerator divided by absolute value of the denominator. But the denominator does not need any absolute value because it is positive, yes? But to make it more clear, I can write it in this form. Instead of x squared, I can write absolute value of x squared. So it is very clear that this cannot go beyond 1, and it is always positive. So this function is indeed bounded.
Okay.
Yes? So don't take these intuitions, you have to follow the definitions. You can draw the graph, but I don't want to spend so much time on these things because there is, as always, we are in the stress of time. But this function at least is bounded. Yes. Okay, and this is the best I can say, that this function, this integral diverges, because one of them diverges to plus infinity, the other one to minus infinity. So I cannot say anything about the overall. But one thing that I want, so first of all, I want you to see that your expectation that this integral is 0 was not correct here. So even though this function was odd, and it goes from minus infinity to infinity, but the answer was divergent integral. It doesn't converge. But if I calculate the, just one exercise, if I want to calculate the Cauchy principal value that I crossed over, this is not the definition of this one. If you calculate this, what you get is called the Cauchy principal value of this integral. Can you tell me what is the Cauchy principal value of this integral?
0.
It is 0. Okay, why? Because if I want to calculate the Cauchy principal value, so let me change my color. It is not related to this lesson, but it is good to see at least once. So if I calculate the Cauchy principal value, so let me write Cauchy principal value is equal to the integral from minus r to r x divided by 1 plus x squared dx, and then I want to take the limit and r goes to plus infinity. Do you agree? This is the Cauchy principal value. So you don't have anything to do, I'm just for extra information. But this function, this integral is what? This integral is definitely 0 because the function is odd and it goes from minus a number to positive of the same number. They are not minus infinity or infinity. According to what we learned before, this integral for any r is 0. So this means that I am calculating the limit of the 0 function when r goes to infinity, but of course this becomes 0. So the principal value, the Cauchy principal value is indeed equal to 0. But if this question is given in the exam and if you answer 0, that is wrong. So be careful about that. So this green part is not part of the solution. So let me immediately go to the next one. Integral. These two examples, one after the other, I think they will be instructive for you. So I will have another integral from minus infinity to infinity, but this time I have x over 1 plus x to power 4 dx. The only difference is that instead of x squared, I have written x to the power of 4. Again, what type of function you are facing? It was an odd function here, but you realize that the answer to this was that the integral diverges. Here, you also have an odd function, do you agree? Because if I replace x with minus x, the denominator does not change, but the numerator picks a minus sign. Okay.
Is it a fast way to check if it's even or odd by just doing x divided by x to the 4 and then you get 3 as the...
No, don't make it complicated. Change x to minus x to see what happens. If it goes back to itself, it is even. If it picks a minus sign, it is odd.
Okay.
So this is already a simple thing, so why I want to make it even simpler? There is no simpler way than that.
Can we also just say that if we multiply an even function by an odd function, we get an odd function?
That is true. That is true because if the function is complicated, maybe I will use those theorems.
I mean,
Yes, you are right. If it's odd, this is even. When you divide them, it becomes odd. Okay, but here now I want to continue. So if this is given in the exam, what you are supposed to do, you are supposed to calculate your, investigate two integrals. One integral is what? Integral from minus infinity to 0. So if you don't mind, let me first investigate the 0 to infinity one. So these two integrals we have to consider. So in the exam you write, in order to answer this question, I will first investigate these two integrals. Okay? Oh, this is power 4, sorry. Thank you. So 1 plus x to power 4 dx. So you write in the exam that in order to answer the question, I will investigate these two integrals separately. Okay? So if I want to investigate this integral, do you remember I give it r, I define a function for myself, and I go from 0 to r. And I try to see what can I say about this integral. Okay, and then let me guide you something. In these questions, if you see, let me show you the question. This is also a good hint. Here, evaluate each of the following integrals or show that it diverges. When you say evaluate, Because sometimes in the future lesson you will see that they just ask you, is it divergent or convergent, without telling you evaluate it. It means evaluation of the integral is more or less impossible. Okay? So this is the question, this is the first simple questions we are facing. They are mentioning that evaluate each of the following integrals or show it diverges. Okay? So here it means that somehow the person who designed the question knows that this integral is doable. Because they are asking you evaluate it if it converges. Okay? So if it is doable, it means that you have to go back and then review what technique you have in your toolbox to do this. So what should I do?
Partial fraction.
Partial fraction is working. Yes, definitely. Because that's a polynomial divided by a polynomial, and then the degree of the denominator is bigger. But do you remember, this is fourth degree. If you want to use the partial fraction method, what you have to do, you have to factorize this. And then how many of you can factorize x to the power 4 plus 1? It is doable, but even I know how to factorize it. I would never do that because it is too lengthy. But if you want to factorize it, let me tell you the trick. So x to the power 4 to plus 1, you write it as x to the power 4 plus 2x squared plus 1 minus 2x squared. Yes? And then these two becomes what? It becomes x squared plus 1 squared, and this one you write it as minus the square root of 2x to the power 2. And then I use conjugate rule. So it becomes x squared plus minus the square root of 2x plus 1 multiplied by x squared plus the square root of 2x plus 1. Yes? And that's the dead end, because the discriminant of each one of them is less than 0, so I will not be able to continue. But even if you could do it on your own, it would be still horrible. Do you remember? Because what type of fraction we will face? 2 second degree, and then I will have ax plus b on one of them, cx plus d on the other one, so 4 unknowns. We have to solve those systems. Okay, so be lazy. This is the first thing. If you want to be a good mathematician, there is a very unwritten rule to be lazy. To be lazy means that, oh, this is too much to do. Let us try to let us to be creative. Yes? Yes?
Is the substitution with x as u equals x squared? Or?
Very good. You take u equals to x squared, yes? So, what I will do, I would say that let u be equal to x squared. Why this is good? Because the derivative of u becomes 2x, and you see x here up to a constant. And it's always good, okay? So if you have this, then what happens? Then you immediately know what to do. Du becomes 2x dx, but then you see that in the original integral, I have only x involved, so I divide by 2, so x dx becomes 1/2 du. And because this is a definite integral, I prefer to use the substitution rule for definite integrals, meaning that when x goes from 0 to r, this then implies a u, my u, goes from where to where? If x is 0, u is 0. If x is r, u is r squared. Yes? So this means that I of r becomes equal to the integral. Instead of going from 0 to r, I go from 0 to r squared now. Instead of x dx in the numerator, you see x dx, I put 1 over 2 du. And then, can you tell me what should I write for the denominator now? Because you know that everything should be written in terms of new variable. You shouldn't have any track of the old variable.
1 plus u squared.
U squared. Yes? So then what happens? I pull this 1 over 2 out, then this becomes integral of du, and this is a very famous integral, hopefully. So what is the answer to this integral? R tangent. So this becomes 1 over 2 r tangent of u. But I have to run it from 0 to r squared. I replace u with r squared, and I replace u with 0, but r tangent of 0 is 0. So this is simply I of r becomes equal to 1 over 2 r tangent of r squared. Yes? Are you following or not? Okay, so then what should I do? Do you remember? This one is this one. So I have to send r to plus infinity. So can you tell me? So now we calculate the limit of I of r and I send r2 plus infinity, which is the limit of 1/2 arctangent of r squared, and then r goes to infinity. I'm waiting for you. What's the answer? Pi over 4. Why? Because this becomes arctangent of infinity. If you remember those lessons, the limit of arctangent when the argument goes to infinity is pi over 2, and this is 1/2. So it is pi over 4. So here, this means that I have to do the other one as well. Yes? So I have to do this one as well, because the first one converges. If I am lucky, or I don't know if you call it lucky or not, if this is convergent, then I add both of them. Otherwise, I would say that, okay, whatever I did is in complete vain. It's wasted of time. It means that if I had started from this one, I could have easily said that this is divergent. So that's the logic you should have. Okay, but what do you think about this one? So let me call J. Which function you define now? So we'll do that and we'll have a look. So what function do you think I will have? Let me call it J of R this time, because that's another integral, but it goes from minus infinity to a number. So I will define J of R to be what? Integral from R to 0, x divided by 1 plus x squared dx, and then I ask myself, what is the limit of JR when R goes to negative infinity? That's my target. Okay?
Is an x to the power of 4.
Ah, yes, exactly. Yes. Okay. You can redo this from the beginning, but you really don't need, because most of the things you have already done. How can I use this more effectively, you know? So, what will change, do you think? I hope that you agree that this will remain the same by the same trick. Okay, so this becomes, if I want to continue, this becomes equal to the integral. This will be by the same trick. Nothing will change here. So what will we change here and there? This becomes what? R squared. Yes. That will become, are you following or not?
0.
0. Because I am just introducing u again. U is x squared. The same trick. So what happens when I put x to be r, u becomes r squared, and here becomes 0. But do you see that this integral, forget about the name, that's just the name. How this integral is connected to this integral?
It's the same thing, but you subtract r squared instead from 0. So
No, do you remember? That is just a replacement. So I can write it as minus integral, I replace them. Yes? But this is exactly minus I of r. Yes? J of r is exactly equal to minus I of r. That was your I of r. J of r is the same, but these two are changed. Do you remember I told you that if you just flip them, you will pick up a minus sign. Yes? Okay, so can you tell me what is the limit here? So it is minus a half arctangent of r squared. Because I of r is already calculated. I of r is 1/2 arctangent r squared. Okay, so I have to take the limit, but this time r goes to minus infinity, which doesn't matter because I have r squared here. So, limit of j of r, when r goes to minus infinity, what the answer is? This becomes positive infinity again. Arctangent of positive infinity is pi over 2. It becomes minus pi over 4 this time. Yes? So can you just wrap it up? So what is the answer to the main problem? If someone gives you this in the exam, what do we say? What do we say?
0.
Yes. So I would say that the original integral converges to pi over 4, which is the first one, plus minus pi over 4, which is the second one, and is equal to 0. So in this case, I just want you to compare. The previous function was odd. and we had minus infinity to infinity, but the answer was the integral diverges. Here again, I have odd function from minus infinity to infinity, but this time, what your guess was correct. I mean, if you just naively want to use that theorem, coincidentally the answer was also correct. So because this time it is really 0. Okay? So, Cauchy principal value is not part of your lesson, but in the previous case it was 0. But can you tell me what will be in this case, principal Cauchy value?
So 0.
Yeah, it is also 0. And that's the theorem. If the integral converges, the Cauchy principal value will be the same number. But it is possible that the Cauchy principal value is a number, but the integral is not that number. It does not exist sometimes. Okay, so we can have a very short break, and then probably we will continue.
Thank you.